Hello friends, welcome to Learn Math with Alex. In today's video, we are going to solve a trig equation. Okay, so I would advise you pause the video, then you try to solve it on your own, then you compare the answers. Okay, so the trick that we've been given is this one. Solve the equation 2 sine, open brackets, 30 degrees plus x, close brackets, is equal to 3 cos x. Okay, so we are solving for x. So this x here and this x here. Okay, so how do we do it? It's very simple, guys. I'm sure by the time you're attempting to solve this kind of equation, I'm sure you must have done special angles, compound angles, addition and subtraction for all the ratios. That is tan, sine, and the cosine. Okay, so let's dive into it. Okay, so solution. So this is our solution for this problem. Okay, so the given problem is 2 sine, open bracket, 30 degrees plus x is equal to 3 cos x. 3 cos x. Okay, so with this question, when you just look at it, the only tricky part is this side. Yes, where you have the addition of two different angles. You have 30 degrees plus this. By the way, x is also an angle, so we are adding these two different angles. Never should you try to multiply this by that, like we expand normal algebra expressions. No, so for the angles, it's a different approach. So with this one, remember from compound angles, the compound angle for sine when you're adding two different angles. So please remember this statement. We know that the compound angle for sine a plus b is equal to, okay, a plus b, so meaning you are adding two different angles, is equal to sine a cos b plus sine b cos A. Okay, so this is the compound angle formula for addition of two different angles for sine. Okay, so we have sine A plus B is equal to that. So we are going to simplify this, guy. So the question is, why are we doing this? Because it's very difficult to solve for x when you have this ratio, two different ratios, like this one cos, we have cos x, then here we have sine, then 30 plus x. So it's a bit tricky, so we can't just go on and we can't just start solving. So we need to find a way of splitting this or expanding this, and the only way you can expand this is by applying this formula. Okay, so if we had a constant here, if we didn't have a ratio like the way we have cos here, it was going to be straightforward. But in this case, we have to apply the compound angle formula. Okay, so this is the compound angle formula for the sum of two different angles for sine. Okay, so we are going to replace this guy. So what I want you to see is, I want you to see this 30 as your A. Okay, then you see this x as your b. Okay, so in simple terms, so we have a, which is 30, b, which is x. So we are going to replace this expression here by that. So we are going to leave this, the right hand side, the way it is, and we are going to leave this constant 2 the way it is. So we are saying it's going to be 2, open bracket, remember sine a, our a, we said it's 30, then cos b, we said it's x, okay, plus sine b is x, so our b is x, then cos a is 30 degrees rather, okay, is equal to 3 cos x. Okay, so When you do this, now it becomes simple because it's very easy to simplify this. Now we have cos x, sin x, very simple than the way it was. Okay, so in this case, we're going to open the brackets. Okay, so before you open the brackets, you can punch this. You can also punch that. Yes, and if you've done special angles, you know the special angle for sin 30. So this is 2, open bracket. Sin 30 is what? Is half, 0 0.5. Then cos x, which is this one. Then plus, okay, sin x. Then cos 30 is what? So cos x, it's the root of 3 over 2. Cos x is the root of 3 over 2. Then you're multiplying sin x, okay, is equal to 3 cos x. Okay, at this point we can open the bracket, so 2 upon that, 2 times that, we're going to remain with cos x. 2 times that will remain with root 3 sin x is equal to 3 cos x. Okay, so we know that these two are like terms, so we can put them together or they can subtract each other. So this is root 3 sin x is equal to 3 cos x minus cos x. Okay, so we have root 3 sin x is equal to 3 cos x minus cos x is 2 cos x. Okay, so in this stage, at this stage now, we have two different ratios. Okay, so under trig ratios, our main goal is to have one ratio and a constant. So it should be sine angle, maybe a constant this side, or cos, or any between the three, any ratio. It could be tan, sine, or cos. You need to have one. So in this case we have two. Okay, so it's a bit tricky again. So we can take advantage of tan because tan combines the two, sine and cos. And remember we know that tan x is the same as sin x over cos x. So if we can find a way of substituting this, of making sine divided by cos, then we can place tan. So in simple terms, what I'm trying to say is we can take advantage of tan in this case. How do we do that? Okay, I can divide both sides of my equation by cos, even this side by cos, you see. So this and that is 1. So here we're going to remain with 2. Then this side will remain with root 3. And we know that sine upon cos, it's this one, which is what? Tan x is equal to 2. Okay, so when you reach this stage now, it becomes super simple. So this one is now root 3 over root 3 this side. So this and that guy will go. Then we have tan x is equal to 2 over root 3. Okay, so this is all what we wanted. We needed to come up with one trig ratio and some constant. So in this case we have tan and a constant, then we can solve for x. So this is very simple, guys. Now, so our x is equal to the tan inverse of 2 over square root of 3. The tan inverse of 2 over the square root of 3. Okay, so the tan inverse of this value is what? 49.1. 49.1. Then the other one. Okay, so remember when you reach this stage now, you are dealing with tan positive. So this constant here is positive. So when you go in our 4 quadrants, okay, these are quadrants. In the first quadrant, which is this one, all the ratios are positive. In the second one, only tan, so only sine. Third one, only tan, and the fourth one, only cos. Okay, and the equation, so we are dealing with this guy and that guy. So this guy is an acute angle, so this is the angle that we found. So the first quadrant, they're always acute angle, meaning the angles that are between 0 and 90. So it is 49.1 degree. Okay, so the equation in the third quadrant is 180 plus the angle that you found. In this case is 49.1. Okay, so therefore our x is equal to 40.1 degrees, and this is 229.1 degrees. So these are the values of x. These are the value of x. So this is how you go about this one. Thank you so much, guys. I hope you learned one or two things. Please don't forget to like the video. Don't forget to subscribe and to leave a comment below. It could be a suggestion on how I can improve my presentation. You know, I'm just using a phone. This is my first time doing this. Okay, you can propose or you can make different suggestions, and I really appreciate the people that are sending questions, those who are in need of my help. Okay, thank you so much. Please stay blessed.